Hello, everybody. So we are graphing secant and cosecant today. Yesterday's conversation we talked about secant. This dashed line right here, the green one, is cosine, the cosine parent function. And whenever the cosine parent function hits the midline, you've got vertical asymptotes. Now the secant, you would graph cosine first, and then the secant is guided by those two vertical asymptotes, and then it's also touching the maximum and the minimum. So every time there's a maximum, the secant function touches that. Same thing with the minimum. And you use the vertical asymptotes to guide you. Cosecant is the same story, except you would just start with sine, the sine function. So here when x equals 0, notice you're at the midline. So that tells you you're using sine. And whenever the sine function hits the midline, just like cosine, you've got a vertical asymptote. And notice that cosecant and secant, they both look the same. It's just one is shifted over from the other. Same thing as sine and cosine. They look the same, just one is shifted over a little bit. All right, 3 quick pages, and then we're done. Let's work backwards. What is the function of this graph? So looking at this, we know right away it's either secant or cosecant. The truth is it could be either one, just because remember, one is just a phase shift over from the other one. We'll try to keep things as easy as possible and avoid a phase shift if we can. So how do I find out this function? The steps are, you're going to graph either a cosine or a sine wave. Then you're going to figure out what that function is. And the last thing you do is you convert to its reciprocal. So it's a 3-step process. So I want to graph a cosine or a sine wave that is kind of bounded in between those two sections. So that's my sketch. This is why we spent a week and a half on cosine and sine, because if you could draw that graph, then you could come up with a function that represents that graph. Notice right here, when x equals 0, I'm at the top of the hill. So that tells me I'm using cosine. For the blue graph, my maximum y value is 5, my minimum y value is -1. So the thing right in the middle is +2. So that's my midline. I'm going to end in +2. And if I know my middle, I know my amplitude. My amplitude is 3, but is it +3 or -3? Well, depends. If I'm starting right here, it's -3. But I want to start right here. I want to start when x equals 0 if I can. So if I start up there, it's +3. And then the last thing that goes in here is b times x. Well, b is related to the period, and this one's an easy one. Here I can finish one whole cycle in just 2 pi. So the period is 2 pi. And the b value is always 2 pi divided by the period. So it's 2 pi divided by 2 pi, so it's just 1. So there's the function for the cosine wave. 3 times the cosine of x plus 2. How does that help you? You change the cosine to its reciprocal, secant. And this is the function for that graph, that red graph. So 3 steps, guys, 3 steps. Step number 1, well, okay, so you first have to recognize that this graph is either a secant or a cosecant graph. So step 1 would be to physically graph either the cosine or the sine wave. Step 2, based on your graph, come up with either the cosine or the sine function. Step 3, change cosine to secant, to its reciprocal, or change sine to cosecant. Let's practice another one. What is this graph? Again, it's either cosine, it's either secant or cosecant. First thing you're going to do is graph a cosine or a sine wave and try to come up with a function here. Again, I'm going to start, if possible, at x equals 0. And when x equals 0, I'm at the midline. So that tells me I'm using sine. The midline happens to be 4. So my answer ends in +4. And my amplitude is 1, but my a value is -1 since I started going down. So -1 times the sine of what? Well, again, the period is only 2 pi. You just need to travel a 2 pi distance to complete a full cycle. So that means b is 1. It's just 1 times x. There's the sine function. How does that help you? Well, if you want to get the blue graph, then you take the reciprocal of the sine function. So it's cosecant. So you're going to rewrite this whole thing. You're just going to replace sine with cosecant. And then you're done with that. Last one, the most challenging one. You want to find the secant function and the cosecant function that would represent that green graph. There's a few things different here. One, the period is different. And two, I got to do the secant and the cosecant. So when I do the secant, I'm first going to find the cosine. And then the last thing I'm going to do is change it from cosine to secant. To find the cosecant, I'm going to first find the sine. And then the last thing I'll do is change it from sine to cosecant. What's the first thing I do? The first thing I do is, as always, graph the cosine and or sine wave. All right, I'm going to start off easy. When x is 0, I'm at the top of the hill. Let me label this. Let me say 1. That's the starting point. If I start right there at number 1, then I know I'm using cosine because I'm at the top of the hill. My midline is just like that first problem. The midline is 2, the max is 5, the min is -1. So I add 2. And my a value is +3. But what's the period here? The period is smaller. It's pi. Remember, guys, how many cycles do you go through in a 2 pi distance? You went through 2 full cycles. So the b value is just simply 2. Or you can always do 2 pi divided by the period, which in this case is 2 pi divided by pi. And so b is 2 that way. So the red function, the cosine wave, is y equals 3 times the cosine of 2x plus 2. The green function is just replacing cosine with its reciprocal, 3 times the secant of 2x plus 2. That's the secant. That's done. How do you find the cosecant? Well, the cosecant is the reciprocal of sine. So I need to pick a spot that starts at the midline. And it doesn't really matter where. Let's just do this one right here. Let's start right there, number 2. A lot of things are the same. The b value is the same because it's the same period. So it's going to be sine of 2x. The midline is the same. The amplitude is the same. The amplitude is 3, but here it's -3 because starting at position number 2 and the midline, sine would normally go up, but this was flipped upside down. And you've got the sine function. Now replace sine with its reciprocal, cosecant. And I don't know why I'm doing parentheses suddenly, but whatever. And there you have it.